Okay, today is adding and subtracting rational expressions part 2. Now, there was some dire warnings in the last video that somehow this is going to be really difficult. But I'm going to show you some tricks or some ways to handle these questions so that it doesn't have to be quite so scary. So why did it sound so scary in the last lesson? Well, it was really important you did your homework, I guess was the why that was phrased like that. If you did your homework and you sort of get the idea of common denominators, then I just have to show you a couple of management techniques. Okay, so a little more about the lowest common multiple, which we talked about in the last lesson. And I'm trying to speak very slowly and deliberately here, giving you lots of time to copy this down. And I'll even give a little break in the video after I finish A and B there. So if you're panicking to copy, just relax a little bit, listen to what I have to say, and then I'll just give a little break there at the end. So a little more about the least common multiple. Remember that the least common multiple is simply the smallest number into which a given set of numbers will divide. And what we mean by that is we don't want to just take the biggest denominator out there. It's going to make the numbers very big, which didn't seem that dangerous yesterday, actually. It seemed like, well, okay, if the numbers are a little bigger, what's the problem? I can handle it, and I can just reduce the fraction at the end. Well, when we're dealing with rational expressions where there's complicated expressions in the denominator and numerator, you're not going to want to do that. You're not going to want to get things big and out of hand because you're just going to get giant terms and giant expressions. So we really want to focus on using the least common multiple. Although I'll tell you a little secret, I think it's a little easier with variables than it is with numbers. I think so, once you see what has to happen with variables. Anyways, here we go. Starting with some practice, basically the same thing we ended last lesson with. Find the LCM, the least. Oh, mathematicians love shortcuts like this. Like they throw in LCM like that. Like, oh, we've seen it so many times. We know what LCM means. Well, LCM is a short form you see fairly often. But anyways, right above there you see in the note. If you hopefully you're copying, but let me just highlight that least common multiple. Sort of important to know that when you get two questions that say find the least common multiple. Yes? Okay. So find the least common multiple of the following set of expressions. Okay, we start with one that's 5 and 2. Because both these numbers are prime, the trick that you learned way back when of just multiplying them together is the right trick, because 5 is the only prime in 5. 2 is the only prime in 2. So the only thing we're dealing with here is a 5, and the only thing we're dealing with here is a 2. So the lowest common multiple is 5 times 2, which is 10. So I don't want to discount that move. That move is a perfectly good move, but only if the numbers have been factored and brought down to their primes. So for instance, 3, 4, and 6, if I multiply those all together, I get 72, which is a common multiple, but it's going to make all the numbers too big. So I suggested 2 different tricks to get least common multiple, but I'm going to put a little more pressure on the second one this time. My first trick to get least common multiple was just to count by each of these numbers. So up here, I'm going to count by 3s. I'm going to go 3, 6, 9, 12. And I showed you yesterday that you don't have to just keep going forever. What you have to sort of do is look at each of these and see if the other numbers divide into those. Now I see that 4 doesn't divide into 6. 4 doesn't divide into 9, but 4 does divide into 12. So I sort of stop there and go, oh, maybe I've made it. 3, 6, 9, 12. Maybe 12 can work here. Then I check my other one. 6. 6 divides into 12 as well. And in the previous video, I think you saw me make a mistake for a second because I didn't check all 3. I did by the end, but I first wrote something down that actually didn't work. But this time 12 does work. 3 divides into 12, 4 divides into 12, and 6 divides into 12. I don't want to jump ahead too much here, but basically for 3 to get to 12, I got to multiply by 4. For 4 to get to 12, I got to multiply by 3, and for 6 to get to 12, I got to multiply by 2. So there's different numbers that I'm multiplying by to get to 12 for each of those. That'll matter when we go to do common denominator. Now, the other way I suggest is very interesting thinking is to look at each of these numbers and break them into their prime factors. So 3 only has one factor of 3, but 4 can break into 2 times 2, and 6 can break into 2 times 3. That kind of thinking, when it's factored, you don't really need here. You might be looking at this going, well, no, I understand the one you were already doing there. Doing a little housekeeping here while I'm talking. I understood what I was doing there, why you're making it more confusing. And this happens in math all the time, where all of a sudden we take an example that was perfectly fine, we were quite happy with it, and then we do it another way, and it makes it look more complicated. And I guess it is, but we're getting ready for other stuff, getting ready for other thinking here. Okay, so I broke those into the prime factors, and so I look at that and go, what factors do I need here? From the 3, I need 3. Yes? From the 4, I need both 2's. But then when I look at 6, I say I need a 2. I'm like, I already have a 2. I'm fine there. I look at the 6 and I say I need a 3. I'm like, I already have a 3. So I have all the prime factors already built into it, and 3 times 2 times 2 is 12, and I get the same answer. Am I selling that method? Not yet. But I do want you to think about it, because it does come up in the later examples, that kind of thinking. But in an easier way, I think. I hope to explain it in such a way that you go, oh, well, I can handle that in that situation. So I want you to prepare for the thinking, but not necessarily get too intimidated by it just yet, okay? All right, now we sort of change topics for just a minute. And again, this thing is fighting me a little bit, so I got to switch over. Oh, I promised to pause. Silly Mr. Todd. Okay, so I'll just pause there for a second. Literally pause, a little silence in the video while you catch up copying there. And actually what I'll do, just in case somebody is all caught up on copying, I'll just scroll the screen just there, and then you can start copying the next part if you already had that first part done. Okay, so what if there are variables in the set? Seemingly changing topics here a little bit, but it's not. We need this. What if there are variables in the set? To find the lowest common multiple for the set 2 and x, remember we're looking for the smallest expression that both 2 and x divide into. So the lowest common multiple is 2x. And the reason the lowest common multiple is 2x is because 2 and x don't have any common factors in them. 2 doesn't factor, x doesn't factor, and so when I want to get the least common multiple, I just multiply those two things together. Okay, some other examples with some tougher thinking here. The least common multiple for the set x, x squared, and x cubed is, well, these have factors in common with each other. And so x is made up of just x, but x squared has x times x, whereas x cubed has x times x times x. And this is the kind of secondary thinking I was doing on the previous questions to go, oh, to get something that's the least common multiple, if you were stuck to the trick of just multiplying these things together, x times x squared times x cubed, you might come up with x to the 6th. But using my sort of prime factor type thinking, where I go, what is each of these made up from? I realize that x cubed is the least common multiple. X divides into x cubed because it has one of the x's in it. X squared divides into x cubed because it has two of the x's multiplied together in it, or two x's as its factors. And x cubed, of course, divides into x cubed because it is x cubed. Okay, maybe that clicks a little bit. Maybe just a little bit now. I see where we're going with this now. Look at the factors and use those to think out which factors do I need in the least common multiple. So next, 2x, 3x, and x squared. And in other algebra, we've ran into this before, where you can think of the coefficients sort of differently than the variables and say, okay, well, first of all, if I'm looking for a least common multiple, what would the coefficient be? And the coefficient needs to have a 2 and a 3. So 2 and 3 are different, are prime factors, so they both divide into 6. And in this particular case, because they're both prime, yes, I still do my trick of multiplying them together. So that's where that trick sort of came from when you first saw these things, when you originally saw fractions, is that we just take those factors and multiply them together. Next, x, and x squared. And I pause for just a second to let you think about that. and to get my voice back, and think, okay, what do I need here? I need an x. The next one says I need another x. Not another x. I also need x. And then x squared says I need x times x. And hopefully that all comes to x squared. Accidentally activated something there on the bottom there. So I just fixed that up and finished writing 6x squared there. Sorry about that. Okay, just thinking forward a little bit. We don't have to think about this just right now, but 2x divides into 6x squared. So we're going to have to think about what do I multiply 2x by to get 6x squared. That won't be too bad. It looks like common factoring type thinking. And then 3x divides into x squared. So what do I multiply 3x by to get 6x squared? That's all coming later in the lesson because we're going to have to use these as common denominators. All right. Least common multiple for the set x plus 2 and x minus 3. Now, this is the hardest looking question of the day, and I'm telling you it's actually the easiest question. Because each of these are factors in themselves, x plus 2 is one factor, x minus 3 is another factor, life is actually very easy here. We need a least common multiple. We need something that x plus 2 divides into. So x plus 2 is going to have to be a factor. Oh, I'm doing that thing at the bottom again. Sorry, folks. Let me just get that fixed up. There we go. I'll be more careful. So, where was I? X plus 2 needs to be a factor in this least common multiple. But also, x minus 3 must be a factor. And that's the end of the game. So, when there's binomial factors like that, like an x plus 2 or an x minus 3, finding the least common multiple, very straightforward. It needs to have each of those factors in it. It needs an x plus 2 and an x minus 3. And if you're right with me, you're like, okay, so we're sort of right back to what you said not to do, which is just multiplying the two factors together. Okay, well, if I said don't multiply them together, what I meant to say and what I should have clarified was don't only do that. Look at carefully what you're doing. There will be times when you do that. Sometimes that's a perfectly good move. And in this case, it is the right move. To which, that's troublesome, right? And you're like, well, how am I going to know which way to do it? And the answer, unfortunately, like a lot of algebra, is just experience and practice, okay? But anyways, hopefully C is actually good news. That you look at it and go, okay, well, if there's these binomial, like x plus 2 or x minus 3 factors, if I want the least common multiple, I just need something that has both those factors in it. One little note here, and again, I'll pause here if you're scrambling to copy. Why do we care about the least common multiple? When adding and subtracting rational expressions, oh, this needs to be highlighted. We need to find a common denominator. We know that. Usually, the least common multiple is most efficient. And maybe you didn't care about least efficient before. You're like, well, what do I care? But I'm telling you, with rational expressions that got variables in it, and you're going to see as the examples ramp up here, you're going to want the most efficient one. Otherwise, things get completely out of hand. The algebra is going to get completely nuts. So, to find the least common denominator, we simply find the least common multiple of all the denominators. That's something that's been mentioned before, but again, it gets the nice highlighter here to go, woo, this is important. Slight pause there for you, so you can catch up copying, or you can take a bite of your snack, or you can peek at the homework. Another great move during video lessons like this, just to peek at the homework and go, how does this play out in the homework I'm about to do? Okay, hopefully that was enough time to copy. If not, maybe you'd like to pause the video. All right. So to manage your energy, I've got to do some examples here. A, B, C, D, E, F, and they're a lot like what the homework questions are. So these are the ones to really zone in on. I mean, you should zone in all parts of the lesson, I suppose, but this is the time where you're like, okay, extra brain power. Really get into it here. So, simplify the following and state the restrictions. So the state the restrictions thing keeps coming back to haunt us. And like I said before, I think a really good move is as you go to hand in your test on test day, you should be, just as you're walking to the desk, you're scanning down to see that you stated restrictions all the way. I'm going to do it at the end on the first one. I'll do it at the start of the second one, just to establish that there's two different ways to handle this. Okay, first, we see this as adding rational expressions. We see this as adding fractions, which means we need a common denominator. To get the common denominator, we want the best one, the one that's going to be most efficient here. And to do that, the least common divisor is the one that we want to get there. Sorry, least common denominator is going to be that least common multiple. So lowest common divisor here of x and x squared. We know we need an x. We know we need another one that has x and x. So actually x squared will be the most efficient one. It has x in it. It's also got x squared in it. Now, key moment in the lesson to understand how I'm going to handle this, and I promised some tricks or some management techniques to make these questions actually hopefully not that bad. Here's my management techniques. Watch this. I'm going to write something here that you're going to be completely underwhelmed by, but it's to be the best thing I write all day. I'm going to rewrite that line of 2 over x plus 5 over x squared, but all I've done there is make a little more space. I've just opened things up a bit so I can do the math magic I got to do here to make this happen. Okay, I want to get to a denominator of x squared in both of them. Good news in this one, the second term, 5 over x squared, already has x squared in the denominator. But I want the first one to have denominator x squared. So then the big moment is I got to think about what can I multiply x by to end up with x squared. And hopefully you know the answer is x. And just like when you first learned fractions, I'm going to multiply top and bottom by the same thing by x over x. Now I've used a dot for multiply there. A common algebraic move instead of using an x for multiplying there. And so I multiplied by x over x. And from previous lessons, what you're really multiplying by is 1, which you're always allowed to multiply by 1. It's one of the most powerful, famous math moves there is to multiply by 1. I've chosen x over x here, and the reason I've chosen x over x is now the numerator becomes 2x, which is slightly interesting, but the denominator becomes x squared, which is very interesting. I've chosen exactly the right the right 1, x over x, to make this have a common denominator. Once you accomplish that, you should be smiling. You should be like, yay, I did it. Because life should be easy after that. When you add rational expressions and you have a common denominator, all you do is add the numerator and keep the denominator the same. So when these things get crazy, and they will, remember, once I have the common denominator, the steps are simple. I didn't say easy. The steps are simple. Add the numerators, keep the denominator the same. Now, don't forget, comma, x can't be equal to 0. That's my restriction. Many teachers will say state them at the start. And that is very wise advice. It has to do with not forgetting to do the restrictions. You really are supposed to state them at the end as well. So sometimes I just do it at the end because I trust myself not to forget to do it. So I'm going to put it back up there because I don't want to go against other teachers' advice, which is to state it at the start. As we found out when we divided them the other day, stating at the end, there might be new ones in there. That's why I like state them at the end. But okay, on to the next one. We will continue to battle with that. Let's do that right off the top this time. Let's use that other teacher advice, wise advice, to go state restrictions right off the right at the top here, and up here I'm going to write x can't equal 0 because I see that an x of 0 would make the first denominator 0. It's also x 0 that'll make the second denominator 0, and it's also x of 0 that'll make the third denominator 0. Now, lowest common divisor, least common multiple. I see 5x, 2x squared, and x cubed there. And like usual, in these situations, we can look and see, okay, let's do the coefficients separately. what is the lowest common divisor for 5 and 2, and that's a 10. And then I see x squared, and x cubed. And so the lowest common divisor for those would be x cubed, because x divides into x cubed, and x squared divides into x cubed, and x cubed divides into x cubed. Now, my management move. Wake up. This is the moment where I try to make these workable. If you're having trouble with all this, my move is to rewrite that line. And all I'm going to do is get some space. And then I look at each of these in turn. I go, okay, 4 over 5x. What do I have to multiply top and bottom by so that the denominator becomes 10x cubed? I look and go, well, the coefficient is a 2. And xy is x multiplied by something to give x cubed. I need an x squared. So I got to do that at the top as well. See, I'm really multiplying by 1. But I just got to choose the right one, the right thing to multiply top and bottom by to get 10x cubed, because I've decided that's my denominator, 10x cubed. Next one. What do I multiply 2x squared by to get 10x cubed? Let's see. 2 multiplies by 5. X squared multiplied by x. So I multiply top and bottom by 5x. And then the last one, there's often an easy one in these. To multiply x cubed by to get 10x cubed, I got to multiply by 10 over 10. On the next line, I do that multiplication. 8x squared. Goodness gracious. Tidy up a bit here. 8x squared over 10x cubed plus 15x over 10x cubed plus 10 over 10x cubed. If you're happy, good. If you're unhappy, you're probably unhappy I didn't distribute. But I don't distribute here because it's all multiplication. There's no adding or subtracting in any of these denominators. Distribution is for when you have things that are added and subtracted. This is where I'm going to put my smiley face. That's not really proper algebra to put a smiley face there. That's just me going, okay, life is good now. I see common denominators. And you have to continue to keep your algebra endurance up, you have to celebrate sometimes in algebra and go, there, that's good. Because now that I have a common denominator, I just add the numerators, but keep the denominator. Pause there and let you think about what else I have to do. Well, I'll tell you one thing, and I hope you noticed it. Maybe you're looking back and forth with your friends at this time. In my excitement to explain the example, I messed up something. But this gives an important example for me to talk about. And I didn't do this on purpose. That would have been awesome if I had done this on purpose so I could have this talk, but I do want to have this talk. After you finish one of these questions, you should look back and see check each line and say, how did it go? I'm going to notice right off the bat, I missed the minus on the second term. And maybe you noticed it, maybe you didn't notice it. And then it's awfully frustrating because it's awfully tempting to erase everything. Here's some good algebraic advice. Don't erase lots of algebra until you know what's wrong. Right? So if you were to check this answer in the back, you'd see it's wrong. And it's awfully tempting then just to erase it in frustration and say, oh, I'm terrible at algebra. And we've got a saying in calculus that goes, it's always a negative. Because it always is a negative, it just seems like. And in this case, it is the negative. So let me just, before I erase like crazy, I'm going to go, well, that's incorrect then. That should have been subtract. And so I look at my next line and go, well, it's very salvageable. Everything else is correct. But that should have been a subtract. And that means in this line here, instead of adding that 5x, I should have been subtracting that 15x. Sorry, I misspoke there. Okay? So I waited until I knew what was wrong with it. Then I go back and fix it. And so lots of times you can be very disappointed in yourself and get the wrong answer. And you think, oh, I'm not very good at this. And then you go back and find out, well, it's just a negative. I was actually pretty good at this. I just made one little mistake here. And here comes that restriction at the end. X can't equal 0. All right, 4 more to go. 4 more to go. Let's move that up to there. Now, a little advice here, and this gets the red highlighter. Ooh, the red highlighter. For me, I learned this from my daughter. Red highlighter means danger, or not danger, like, hey, gotta remember this. Got to remember this. I think she actually used to use pink, but in my classes, I always talk like she used to use red. There we go. Always factor first. Okay, even right here it says find the lowest common denominator. No, not yet. Oh, I gave it away. Darn. First factor the denominators. So the denominator here has a common factor. And the denominator here has a common factor. And that's going to affect my choice for the least common denominator. So, watch this. Once factored, finding the least common denominator. I made a little reference earlier in the lesson. I said, oh, it's actually easier when it's algebra. And I think it is, because look, my least common denominator is going to have a 2 in it from the first denominator. It's going to have an x minus 2 from the second denominator. And then it needs an x okay, then the second denominator says I need a 2, which we go, yep, got your 2, no problem, we're good already. And then it says, oh, I also need an x minus 3, and I go, well, I don't have an x minus 3, so there's the lowest common denominator. So here comes my management trick here, is I'm just going to buy myself some space. That is, I wrote that there, and I wrote that over here. Just a little space there to do what I got to do. And I look at that first denominator and I go, okay, the first denominator needs a 2 and an x minus 2. Oh, that's what it has, a 2 and an x minus 2. But my denominator I want also has an x minus 3. So all I'm going to do is multiply top and bottom by x minus 3. That is lovely mathematics. That management technique of just buying yourself a little space so you can multiply top and bottom by what you need to. This one, it has the 2. It doesn't have the x minus 2 yet, so I need to multiply top and bottom by the x minus 2. But it already has the x minus 3. So let me just rewrite that out. The numerator of this first one is x bracket x minus 3. The denominator of this one is 2 bracket x minus 2 and x minus 3. The second one is 3 and x minus 2. And the denominator, well, it's in the wrong order. See, it's 2, x minus 3, and x minus 2, so I'm just going to write that in the proper order here. I didn't really do anything there. I just wrote that in the order the other one is. All right. Well, we're in good shape. We've got a common denominator. I don't have any space for my smiley face, but trust me, I'm smiling here as I make this video because I've got the common denominator. So, little problem here, though. The numerators have this distribution that has to happen before I can be subtracting these. So it's x squared minus 3x all over this 2x minus 2 and x minus 3. And this is minus 3x minus 6 all over 2x minus 2 and x minus 3. And now finally I can put them together over one denominator. X squared minus 3x, oh boy. Number one error in algebra, I think at any level, is right here. When you're, let me just highlight it back in yellow. When you're subtracting a negative. See, I've got to subtract that whole second term, that whole second rational expression, but that means subtract the 3x, which I did, but it also means subtract the negative 6, which would actually be adding 6. You just take note of that because that's going to be your number one error tonight. And by far, that'll be the number one error tonight. X squared minus 6x plus 6 after I tidy that up. And the bottom is 2, x minus 2, and x minus 3. Now, once in a while, that numerator will factor, and more has to be done here. This particular one doesn't, but you should always check to see if that numerator factors, which it does not. All right, just a little pause there, just in case you need to do any copying. And now, over to this one. Whoa, not over to this one. Silly, Mr. Todd. Goodness gracious. Then state the restrictions. X can't equal 2 or 3. Maybe you're thinking, oh, if you had stated them at the start, Mr. Todd, you wouldn't have almost forgot. Well, that's probably true. However, stick to my move of making sure before you hand your test in, you always check your restrictions. So you either on the first line or the last line, make sure you're doing those restrictions. But I'll learn my lesson here, okay? First step, factor. So the denominator has a common factor of 6 in this first one. It has a common factor of 4 in this second one. And I'll go ahead and state my restrictions. K can't equal -1 or 3. Okay, learn my lesson. State the restrictions at the start. Now, least common denominator, lowest common denominator. Okay, I look at the coefficients, 6 and 4. What denominator will I use there? Let's see, 6 and 4, 6 and 4. Well, I'm thinking 2 and 3, 2 and 2. It's 12, but okay, you can just count by 6s, count by 4. Somehow, whatever trick you got, we need to have a 12 there. That's the lowest number that both 6 and 4 divide into. And then I see from the first denominator, I need a k plus 1. And I see from the second denominator, I need a k minus 3. See? Not bad. Not bad when it has those binomials in the denominator. You just need each one in there. So my management technique, buy yourself a little space to think here. And think about what I have to multiply top and bottom of this first rational expression by to get to the lowest common denominator that I want. I need 12, k plus 1, and k minus 3. Well, I see first of all that it's going to need a 2 top and bottom so that that 6 becomes a 12. It's got the k plus 1. It needs the k minus 3. The other one, it's got the 4, so I'm going to have to multiply by 3 to get it back up to 12. And then it needs a k plus 1 and a k plus 1 because it's already got the k minus 3. Let me just tie that up a little bit because the algebra is getting a little wild here. That's a dot, not a minus. And in fact, lots of times you'll see mathematicians not even write that dot anymore when they have two rational expressions side by side. That means multiply, so like that. That dot starts to look ominous to you. Okay, so first of all, the way I handle this is I go, okay, put the monomials together first. That's got a k and a 2, so it's 2k, k minus 3, over 12, k plus 1, and k minus 3. I've now multiplied that stuff out to get the common denominator I wanted. And over here, handle the monomials. 5 times 3 is 15, times k plus 1, and the denominator now is 12. And I'm just switching the order of that denominator. It's k plus 1 and k minus 3. Oh, I wrote minus 1 on the other one there. Let me just fix that up there. There we go. Now, listen. You can shorten these down when they're adding is less dangerous. I hope you saw over here, and I'm going to hit the highlighter again over here and go back and go right there. When you have minus in between there, that's big trouble. Plus is a little easier because I can totally go like this. 2k, k minus 3 plus 15, k plus 1 over 12, k plus 1, k minus 3. I don't got to worry at all about the distribution here at all. It's all going to work out very good. So I get 2k squared minus 6k when I do that first distribution, and I get 15k plus 5 when I do that second distribution. The denominator I'm not going to distribute out because I don't have to collect down there. That's why I'm not doing that mess. It's already nicely factored. It doesn't have an add sign between it. So then collect up like terms, I think, and then I'm done. 2k squared plus 9k, and that's a 15 out there. I said 15, but I wrote 5. There we go. Ooh, does that factor? Ooh, okay, let's see. AC is 30. Two things that multiply to 30 but add to 9. 1 and 29, no. 2 and 18, no. 3 and 17. Sorry, 3 and 10, no. 4, no, 5 and 6. See, I'm trying to factor that numerator. And so there is the odd question where that numerator will factor. This one happens not to factor. So I just leave it as it is. Leaving some big questions for next chapter. What do we do if it doesn't factor? Well, we'll get to that a little later. And then my restrictions from before. K can't equal -1 or 3. All right. That's pretty good. And the examples in the homework, like I say, are a lot like these ones. So going back to these videos and going back to these examples is going to be hugely helpful when you try this homework. So if you're still a not copying down person, oh my goodness, that is way over. That should have ended in about grade 7, I think. But if it's taken you this long to realize, geez, having these notes down and having them wrote them down myself once is going to help me in the homework, then here's your big moment right now. Pencil, piece of paper. Next example, let's get copying. 2 of them to go. All right, a little tiny bit faster here, just in case it's gone too slow for you. First step, factor. So I see both what type of factoring this is. It's not common factoring. It's not difference of squares. It's 2 things that multiply to 6 and add to 5. That's 3 and 2. Second set of brackets, also simple trinomial factoring. The a value is only 1. That kind of trinomial factoring is not too bad. I need 2 things that multiply to -12 but add to -1. Let's see, multiply to -12. 2 and 6, no, that doesn't. 1 and 12, no, that doesn't. 3 and 4. Oh, it must be 3 and 4 because 3 and 4 are 1 away from each other. So I get y plus 3 and y minus 4. So now I'm going to state those restrictions. Y can't be equal to -2, -3, and +4. Okay, I've got those restrictions ready to go. Now, the common denominator. What will the common denominator have in it? It's got to have a y plus 2, yeah? It's got to have a y plus 3, and it's got to have a y minus 4. Do you see? The y plus 3 repeats. It's going to be in there either way. So, here's my management technique, which I could have done in that last one. Once you get used to me, like, oh, as I'm factoring, I'm going to do Mr. Todd's move of just buying myself a little bit of space to think here. Here it comes, a little bit of space to think. And some little extras here in my management technique to make things a little shorter and easier for you coming up. You don't have to do this with a separate rational expression. They just get multiplied in anyways. So why go through all that work of putting in a separate rational expression? Watch this. I'm going to write it in red. Okay? What I'm going to do is change my technique just here a little bit. I'm going to switch to color red here and watch what I do. If these all seem very long to you, here's my second of my management tricks here, is I'm going to go, okay, listen. I'm just going to extend that rational expression out a little bit. See? And you say, well, you've got rid of all your extra space. No, I didn't. I've left a little space in the denominator, a little space in the numerator to add something. I look at the 2 denominators, and I go, they both need a y plus 2. Oh, so this one's going to need y plus 2, top and bottom. See? They're very close to being each other now. That was great. See, I didn't do the denominator. It's a little more advanced way of thinking there is to go, well, I just got to get each of these denominators to look like the other one. So by putting a y plus 2 in the right-hand expression, it's now got y plus 2 and y plus 3. Pretty good. Next, y minus 4 is in the right-hand denominator, but it's not in the left one. So I'm going to multiply this one, top and bottom, by y minus 4. See? Can go very quickly once you're proficient with that and knowing what you're trying to accomplish. Do you see how both denominators are the same? Maybe you disagree, but they are. They both have a y plus 2, they both have a y plus 3, and they both have a y minus 4. They're just written in a different order, but they are the same. So my next line looks like this. Watch this. This is great stuff. You can do extra steps, but this is wonderful. Oh, I don't need to be red anymore. Let me get rid of that. Back to black. And, ooh, not eraser. Back to black. There we go. The numerator of the first one is 4 bracket y minus 4. I could even multiply those out right now if I wanted to, but I'm not going to. And I'm subtracting the 5y plus 2. And the reason I can do that is because I've got a common denominator. Y plus 2, y plus 3, and y minus 4. That's my happiness step. Oh, now, all I have to do now is multiply out those brackets and collect like terms. Pretty straightforward stuff in the numerator there. The kind of practice you did way back in grade 8 and 9. So I'm going to get 4y minus 16 minus 5y minus 10 over y plus 2, y plus 3, y minus 4. Great stuff, great stuff, great stuff, great stuff. And I get negative y minus 26 all over y plus 2, y plus 3, y minus 4. I'm laughing because I'm looking up and double checking I haven't made a copying error, because sometimes I'm bad for losing a little concentration as I go along there and then making a mistake there at the end. Sorry, a little something has dropped on my screen here, and I'm trying to clean it off, and it's writing all sorts of stuff there. Giving you time to copy, though, which is nice. There we go. All right. Now, that is a very good answer. It is a very, very, very good answer. However, moving forward, and I chose these numbers on purpose so it would work out like this, you're not going to want a negative coefficient sitting on there like that. How can I explain it best? By actually doing it and showing you what it looks like afterwards. When you get in that situation, you're probably going to want to common factor out the negative 1 here. And do you see why? Now that factor looks like the other factors. That is, the variable is positive. Why is that going to matter? Well, then you'll be able to compare it with the other factors more easily. That's just an intro to that. I don't want you to get too worried about that, but I mentioned that as that's a very good move. Will I take a mark off if you don't do that? No. I'm just giving you some advice that you really want to end up with. When it's all said and done, positive coefficients on the y, so common factor out that negative to achieve that. Well, last question of the day, extremely, extremely difficult, has all the stuff in one question. This is as hard as they get. You knock down this one, you're home free. Here it comes. Oh, before I do it, do you notice? I noticed right at the end. You know, I wish you could have seen my eyes there to see what happened. I was about to start that question. My eyes scanned back to the last question to see if there's anything else. Yes, there is something else. Y can't be equal to negative 2, negative 3, or 4. So I hope you caught that. I hope you were seeing that and like, oh, he's going to forget again. Yeah, sometimes I sort of do forget until I go on to the next question, sort of, and then I remember to do it. So make sure you're checking somehow. So, same steps. This thing is the exact same steps, except I've just thrown a couple little curveballs in there. First steps, factor. So I factor this first one. Now, if you can't factor yet something with a coefficient not equal to 1 in one of these trinomials, oh boy, it's time to panic, folks. It is time to panic. You have to either learn how to do decomposition or learn how to do magic X or the use your brain method. There's many other methods out there, actually. There's previous videos. I think there's at least 2 different videos, maybe 3 different videos where I walk through decomposition for you. And if you haven't chosen a method yet, choose decomposition and go back and watch the video and find where I factor one of these. Here's decomp in a hurry for this question. I'm going to buy myself a little space here. Here's me doing decomp. You come up with the AC value. First term times the last term, which is negative 6. You find 2 terms. Sorry, 2 numbers that multiply to negative 6, but add to the b value, which is 5. So that's 6 and negative 1. You use those to break that middle term up, in this case, into plus 6x and minus 1x. Then you common factor in the first set. Any common factor in the second set. And there's that factoring off the negative that I talked about. Then you have your two pairs, 2x minus 1 and x plus 3. Second one, much easier. Two things that multiply to 15 but add to 8, 5 and 3. And then state those restrictions. X can't equal 1/2, -3, or -5. There's the three restrictions. Now, buy yourself a little space, which again, if you're right with me, you're starting to think, when I factor, I'm going to do that extra space. Why are you putting in an extra step? Well, because I'm teaching it, not doing it. When you do it, hopefully you buy yourself that extra space as it's happening. But maybe you're seeing that extra space can be bought in the fraction itself. Because now, all I'm looking for is factors that are in the other denominator. So for instance, the first denominator has 2x minus 1 and x plus 3. And I look at the other denominator and say, oh, it's missing an x plus 5. So I'm going to multiply top and bottom by x plus 5. The second denominator, I go, it's got x plus 5 and x plus 3, but it's missing the 2x minus 1. So I multiply top and bottom by 2x minus 1. The rest is easy. The rest is easy. We've got a common denominator now. I can put those together. 3 bracket x plus 5 minus 2x times 2x minus 1 all over this monstrous denominator. 2x minus 1, x plus 3, x plus 5. Multiply out those brackets in the top. 3x plus 15 minus 4x squared plus 2x all over 2x minus 1, x plus 3, x plus 5. Life is good here. Collect up the like terms here. Negative 4x squared plus 5x plus 15 over 2x minus 1, x plus 3, x plus 5. And once in a while that numerator will factor. This one doesn't happen to, but it's hard to see that it won't factor until you factor off that negative. That's a better looking expression to try to factor. How do I know it doesn't factor? Well, I do my decomposition. I go 4 times negative 15 is negative 60. Is there something that multiplies to negative 60 and adds to negative 5? And the answer is no. Now, if that annoys you, good. That means you're a good mathematician. You're wondering, well, what do we do if it doesn't factor? And you did see what to do in grade 10, but hey, I'll leave it for surprise next chapter. For us, we just have to state those restrictions. X can't equal 1/2, -3, or -5. And I'm done the question. Well, folks, these questions are frustrating and long because one little mistake can cost you. But I promise, I'm holding my hands together in a promise here that the algebraic skills you gain from beating your head on these things and fighting your way through them really, really matter. It's an exercise in getting better at your algebra. So fight with them, check the answers, text me, email me, tell me what's happening, show me your work. I'll point out the errors and you'll move on. Okay? Lots of practice needed. Have a good day.